Do you think that when buying an electric vehicle, all you need to look at is how large the battery capacity is, how far the range is, and how fast the charging speed is? You couldn't be more wrong. If you choose the wrong motor, you might feel completely out of breath when climbing steep hills. Or you might have bought a model with a large battery capacity, yet the power drops faster than anyone else's. Even when you want to overtake on the highway, you will feel a sense of powerlessness as if hitting a wall. When buying an EV, the battery is merely its fuel tank. The motor is its true heart. On the market, there are permanent magnet synchronous motors and AC induction motors, as well as radial motors that you might have heard of but don't quite understand, and even axial motors that are about to disrupt the market in the future. Plus, with various configurations of single and dual motors, it sounds almost like gibberish, right? Don't worry, today, I'm going to help you completely crack the ultimate secrets of EV motors. I guarantee that after listening to this episode, the next time you visit a showroom, the sales rep will definitely not dare to BS you. In this video, I'll break things down into 5 of the most important sections to chat with you. First, we'll understand what exactly makes EV motors are different from traditional internal combustion engines, and why they can give you that terrifying push-back into your seat feeling. Second, I will use the most plain language to analyze the mainstream permanent magnet synchronous motors and AC induction motors, including the love-hate relationships, pros, and cons of these two types. Third, this is the advanced class. I will specifically answer for everyone what a radial motor is, and put it up against the axial motors the top-tier hypercars are frantically developing for an ultimate showdown. Fourth, we will talking about how automakers are playing tricks with these motors, such as front-wheel drive, rear-wheel drive, and what the actual differences are in dual motor or even tri-motor setups. Finally, in the 5th part, I will give you the most practical and down-to-earth car buying guide, teaching you how to pick the perfect powertrain configuration based on your usual driving habits. Let's start chatting from the most basic concepts. Think about it, in the past, when we drove gas cars, for the engines to run, it had to go through 4 steps: intake, compression, power, and exhaust. By the time you step on the gas, the engine RPM builds up, and power is transmitted to the tires through transmission gear shifts. There is a time lag in the middle of this. This is what we often call turbo lag or shift jerkiness. But EVs are a completely different story. The moment an EV motor is energized, it can unleash 100% of its torque instantly. This is why, even for what looks like a perfectly ordinary family electric SUV, the moment it takes off, it can smoke a bunch of million-dollar performance sports cars. Furthermore, the motor also has a special feature that traditional engines absolutely cannot do, called regenerative braking. When you release the accelerator, the motor instantly turns into a generator, using the inertia of the car coasting forward to generate electricity, charging the power back into the battery, while simultaneously slowing the car down. This ultra-high efficiency of dual-use functionality, this is exactly where the charm of EVs lies. Next, let's get into the second key point, which covers the 2 mainstream motors most commonly found in the electric vehicles you can buy on the market today. The first type is called the permanent magnet synchronous motor. This term sounds very hardcore, but you only need to remember its 2 biggest features. It is extremely energy efficient and compact. Why is it called a permanent magnet? Because inside the rotor of this motor, permanent magnets are genuinely embedded. This kind of magnet is not the type of black magnet we stick on the refrigerator. It is made of a powerful magnet, rare earth materials such as neodymium iron boron NdFeB, because it possesses inherent magnetism. It doesn't require extra electrical energy to generate a magnetic field. Therefore, during low-speed takeoffs or stop-and-go driving in the city, its operating efficiency is incredibly high, and its response is lightning fast. If your daily driving mostly consists of commuting to and from work and getting stuck in city traffic, then the permanent magnet synchronous motor is definitely your budget-friendly companion. Currently, over 80% of the electric vehicles on the market, especially those targeting families and emphasizing driving range, almost exclusively use this type of motor. However, it is not without its drawbacks. First, because it uses rare earth materials, the manufacturing cost is relatively high. Second, permanent magnets have a fatal flaw: they are afraid of heat. If the motor operates at its extreme high RPMs for an extended period, such as when you hit the track for racing and the temperature spikes to high. The magnetic force of the magnets will degrade. In engineering, this is called demagnetization. When this happens, the power output drops significantly. So, is there a motor that isn't afraid of heat? Yes, there is. This brings us to the second type, the AC induction motor. This is a classic invention by the famous inventor Nikola Tesla. There are absolutely no permanent magnets inside this motor. It's rotor. It is typically a squirrel cage structure made of copper or aluminum wires. How does it rotate? It relies on an external coil being energized to create a rotating magnetic field, which induces a current in the rotor, thereby generating power. The biggest advantage of an AC induction motor is its high horsepower and high top speed. Moreover, it is extremely durable and completely immune to high-temperature demagnetization issues. If you are an enthusiastic driving fan who loves enjoying that continuous surge of thrust on the highway, or if you frequently drive on mountain roads to enjoy handling pleasures, the performance of the AC induction motor at higher PM ranges will definitely satisfy you. The reason the early Tesla Model S rose to fame in its first battle, it was precisely due to this AC induction motor with its explosive power. Furthermore, it does not use rare earth materials, making its cost relatively easier to control. However, its drawbacks are also quite apparent, because it must first consume a portion of electrical energy just to generate the magnetic field. Its overall energy conversion efficiency is lower than that of permanent magnet motors, particularly when driving at low speeds in urban areas. It consumes more power. Alright, now that we understand the differences between these two mainstream motors, next we will enter the third part of today's video, which carries the highest value. When looking at spec sheets, many people will come across a term called radial motor. It sounds highly profound and mysterious, and some might even think it is some kind of the latest technology. In fact, this is a term referring to physical structure. The permanent magnet synchronous motors and AC induction motors we just discussed, when categorized by structure, 99% of them belong to radial flux motors, shortened to radial motors. What does radial mean? You can imagine a cylindrical front-load washing machine. When the motor rotates, its magnetic flux lines run along the direction of the radius, meaning they radiate outward from the center, or penetrate inward toward the center from the perimeter. This cylindrical design has been the most mainstream form of motor development for over a century because its manufacturing technology is highly mature. Whether it's mass production or cost control, it has already been optimized to the limit. Therefore, the EVs you buy today are basically packed with radial motors under the hood. Since there is a radial direction, are there other directions? Exactly, this brings out the disruptive tech that top global automakers and hypercar brands are frantically chasing after, called the Axial Flux motor, or Axial motor for short. If we say a radial motor looks like a front-load washing machine or a long soda can, then an axial motor looks like a flat pancake or a dorayaki pancake. Its magnetic flux lines do not run along the radius. Instead, they travel parallel to the motor's rotational axis. What kind of superior advantages does this design offer? First, it is incredibly thin and lightweight. Under the same power output, the weight and volume of an axial motor might be only a half or even a third of a traditional radial motor. Second, its torque density is shockingly high. Because it has a larger surface area for force generation, it can unleash extremely violent torque within a tiny volume. You might ask, since it is so amazing, why don't affordable EVs on the market today all switch over to axial motors? Because it is incredibly difficult to manufacture. When an axial motor runs at high speeds, the electromagnetic pulling force between the rotor and stator is immense, demanding extreme material strength. Furthermore, because the size is so small, heat dissipation is also a major headache. Currently, its manufacturing cost remains sky-high. Therefore, right now you can only spot it in multi-million-dollar hypercars. For instance, Ferrari's hybrid hypercars, the McLaren Artura, or the Yasa motor technology acquired by Mercedes-AMG. However, with technological progress over the next 5 to 10 years, this lightweight yet powerful axial motor will definitely have the chance to gradually trickle down to performance EVs that everyday folks can afford. Having discussed motor types and structures, our fourth key point looks at how automakers play with different combinations. The biggest difference between EVs and gas cars is that EV motors are very compact. As a result, automakers can freely place the motor in the front, the rear, or put them in both front and rear. The most common setup is the single motor configuration. In the traditional gas car era, front-wheel drive was the mainstream because putting the engine in the front saved the most space. But things have changed in the EV era. Many automakers are starting to return to rear-wheel drive, placing a permanent magnet synchronous motor on the rear axle. The front wheels are solely responsible for steering, while the rear wheels push the vehicle forward. This kind of design makes the vehicle's steering highly agile, massively improving handling, and during acceleration, the weight shifts back, giving the rear tires even better grip. This is also why many family electric SUVs today manage to deliver a sporty driving feel. Now, if you have higher demands for power, or if it frequently rains or snows where you live, and you require superior traction, then dual-motor all-wheel drive is your top choice. The coolest thing about dual motors is that automakers can mix and match. Many clever vehicle lineups nowadays will simultaneously use both types of motors we mentioned earlier on a single car. For instance, placing a permanent magnet synchronous motor on the rear axle as the primary power source ensures energy efficiency and high refinement for daily driving. Then, an AC induction motor is placed on the front axle. When you're just cruising smoothly around town or using cruise control, the induction motor on the front axle completely powers off and goes to sleep, turning the vehicle into a pure wheel drive efficiency vehicle. However, the moment you stop on the accelerator and need to overtake or climb a steep hill, the front induction motor springs to life and engages within a single millisecond, giving you full all-wheel drive, maximum grip, and a surge of wild, doubled horsepower. This kind of hybrid configuration can be said to perfectly balance range with extreme performance. Of course, if you are a performance fanatic with bottomless pockets, there are now monster-tier models with tri-motor or even quad-motor setups, such as one motor on the front axle and separate motors for the left and right rear wheels. The most terrifying aspect of this setup is torque vectoring. While cornering, it can accelerate the outer tire, while slowing down or even reversing the inner tire. This allows a heavy 2.5-ton large EV to handle on mountain roads with the agility of a lightweight hot hatch. This is no longer a realm achievable by traditional mechanical parts, but pure magic relying on computer processing and instantaneous motor responses. Alright, after hearing so much hardcore knowledge, let's wrap it up in the fifth part. How exactly should you make your choice? Actually, the answer is incredibly simple. You need to be honest with your driving habits and actual needs. If your driving scenarios consists of city commuting 80% of the time, picking up and dropping off kids at school, heading to the hypermarket on weekends, and occasionally driving across counties to visit family, and you are highly sensitive to electricity costs, car maintenance expenses, and the initial purchase price, then I strongly and absolutely recommend that you choose a new wheel drive or front-wheel drive model equipped with a single permanent magnet synchronous motor. That is more than enough, because this configuration is the most energy efficient and highly optimal for you. And single motor vehicles are lighter in weight, which also causes less wear and tears on tires. The subsequent hidden ownership costs will be the most economical. You absolutely must not spend hundreds of thousands more on a dual motor version just for that extreme pushback feeling you use less than twice a year, only to haul that extra, unused motor around the city every day, wasting energy. But if you are someone who insists on driving pleasure, loves carving mountain roads, and enjoys the composure brought by high horsepower, or if your living environment frequently requires driving on steep mountain inclines, or often encounters slippery, rain-soaked country roads, where you need better vehicle traction control, then don't hesitate. Go straight for the dual-motor, all-wheel drive version, especially the blended setup featuring front induction and rear permanent magnets. It can absolutely satisfy your thirst for performance, while keeping the battery from dropping too drastically during highway cruising. As for those who chase the ultimate lightweight design and want to experience the god-tier technology of Axial Motors, currently you might need to prepare tens of millions to order a top-tier hypercar, or we can patiently wait together for a few years for the technology to scale and costs to come down. In summary, in the world of electric vehicles, there is no single motor that is absolutely perfect. There is only the motor that best suits your lifestyle. Understanding motor characteristics equals mastering the soul of an EV. I hope today's video has helped You fully synthesize these seemingly complex technical jargon terms. Next time you step into a car showroom, how fast this car's 0 to 100 kilometers per hour acceleration is. You can act like an insider. Calmly looked at him and asked, "Excuse me, what kind of motors are equipped on the front and rear axles of this car respectively? Are they permanent magnets or induction?" Trust me, the sales rep will definitely look at you in a whole new light and absolutely won't dare to give you an overpriced quote.